Hi, this is Miss Pellegrin, and today we're looking at Module 3, Lesson 2, Generating Equivalent Expressions. So Lessons 1 and 2 go together, and so our outcomes are the same as they were in Lesson 1, that we are looking at addition and multiplication being done in any order using that commutative property and that associative property. We've been using those words a lot. That we can do that with addition and multiplication, but we can also change subtraction to adding its opposite, and we can do division by multiplying by the reciprocal on all of the problems before we start moving things around. You cannot mix addition and multiplication, so we can't mix up our variables there. Okay, so in your opening exercise, if we look at our first example, we have the expression. So the expression is 1. The opposite of 1 is -1. And so the proof is that we're looking that it has a sum of 0. So 1 plus a -1 equals 0. Okay, so the opposite of positive 3 is -3. So 3 plus -3 equals 0. The opposite of -7 is positive 7. So -7 plus 0 equals 0. Okay. The opposite of -½ is positive ½. So -1/2 plus ½ equals 0. So the opposite of positive x must be -x. So x plus a -x equals 0. No matter what the number is, its opposite is going to equal 0. So if I have positive 3x, the opposite of positive 3x is -3x. So if I have 3x plus a -3x, it is going to equal to 0. So 3 times a number plus -3 times that number, well, that's going to give me a positive number. This is going to give me a negative number, and they're going to be the same number because they are both x. So it equals 0. Okay, so then we have the opposite of x plus 3 would be a -x plus a -3. And we could put that in parentheses to separate it. Okay, so to prove that, we have x plus 3 plus -x plus -3. Okay. So if we did the commutative property, change the order, we have x plus -x. So we're putting our x's together, and then we have 3 plus -3. So we're putting those together. Oops, plus sign between there. Okay, so we're grouping it. The x's together, that equals 0. The 3's together, that equals 0. So the whole thing equals 0. And then finally, the opposite of 3x minus 7 would be -3x and plus 7. Okay. So to prove that, we have 3x minus 7 plus a -3x plus 7. Okay, so we would change this, so 3x plus a -7 in order to move it around, plus -3x plus 7. And so then we can move it around. I'm going to come out here to do that. Okay, so 3x plus -3x, that together gives me 0, plus the negative 7 plus 7, so positive 7 and negative 7 equals 0. Okay, so we're just proving that opposites are equal to 0 in order to help us with our lesson today. Okay, so in this example, we're asked to subtract these two expressions. Okay, so if we did the opposite of the sum and the sum of the opposites, okay, so we have subtraction that we see there, so we're going to change it. So this way is going to be the opposite of a sum is the sum of its opposite. Okay? So 40 plus 9 plus, so we're changing the subtraction to sum of negative 30. Okay, sorry, I'm not going to do it this way. Okay. We're just going to add the inverse. Okay. Add the inverse. So we have 40 plus 9. We're going to change that to addition. So then we have to do the opposites of both of them. So sum of the opposites. So because those are in parentheses, so negative 30 plus a negative 2. Okay, so then we have 40 plus 9 is 49 plus negative 30 plus negative 2. Okay, so then I'm going to do the 49, I'm going to do the 30 and the negative 2 together, which gives me plus a negative 32. And 49 plus a negative 2 equals 17. 9, 8, 7, 4 minus 3 is 1. So 17. If you did the order of operations, okay, you have 40 plus 9 in parentheses minus 30 plus 2 in parentheses. So 40 plus 9, we do it inside of the parentheses first, minus 30 plus 2 is 32, so 49 minus 32 is 17. Okay, so they are equivalent. Now, you might say, okay, order of operations, that was a whole lot of steps than we had to do for the other part. However, when we get to part B where we have a variable in there, that's where it's going to become important to us. Okay, because you can't combine the things that are in the parentheses. Okay, you can't do 4x plus 11 and call that 15x. Okay, they're not like terms. You can't combine them. Okay, but we do have some like terms over here. So 3x and 4x, those are alike, but we need to show it in this way first. We need to show that additive inverse. So 3x plus 5y minus 4. Okay, so that's what we had at first. And then we're changing subtraction to addition, but then we have to do the opposite of both of the things that are in there. Okay, so plus a negative 4x plus a negative 11, doing the opposite of both things that are inside of those parentheses. Okay, now we can put together the things that are alike. So we have 3x plus a negative 4x plus 5y. And then we have these constants, 4 plus a negative 11. Okay, so when I do, this is what I'm doing first. I'm just putting the parentheses around it so you see that it's what I'm doing first. Negative 4 and 3 is negative 1. I don't put the 1, I just put the x. Plus 5y, there's nothing to combine with that. And then plus negative 4 plus negative 11 is a negative 15. Okay, but we don't end with two signs. So plus sign and minus sign, they're together. Is that subtraction is the same as adding. It's opposite, so it's the same as saying minus 15. Okay, in example 2, find the sum by aligning the expressions vertically. So we're just going to look at it in a different way, vertically this time. Okay, so we have, and I'm going to write it out again, because you probably can't write as small as you have, minus 6c. And so then we're going to line up what we have here. Okay, hold on. I forgot something. Sorry. I saw subtraction, so I needed to do, I can't do this until I have all of my subtraction as addition. Okay, so 5a plus 3b plus a negative 6c plus 2a, there's a subtraction sign, it's changing to addition, plus a negative 4a plus 13c. Okay, so that's what we're going to be aligning vertically. So 5a plus 3b plus a negative 6c. And then we have 2a. This is supposed to be a b. Plus a negative 4b plus 13c. Oops, there's supposed to be a c there. Messed that all up. Okay, so we're adding those things together vertically. So we see our c's we can put together, 13 and negative 6. So the positive is greater, so it is going to be a positive number. And it gives me a positive 7c. 3b and negative 4b is a negative b. So negative b. Plus, and then 5a and 2a is 7a. So we're just adding up those coefficients. So we're left with 7a plus negative b plus 7c, and we do not keep it with those two symbols there. So subtraction is the same as adding the opposite, which is what we have. So 7a minus b plus 7c. No like variables there. No like terms. So that's all. Okay, and so then in part B, we're going to do the same thing. Okay, so every time I see subtraction, we want to change it to addition first. 2x plus 3y plus a negative 4. So you can just see that the subtraction sign just is going with, you're still taking away 4, plus a negative 4. It lets us move it around differently. Okay, So we're changing that subtraction sign to an addition sign. Okay, and we have to do the opposite, but we have to do the opposite of both things that are in the parentheses after. Okay, kind of like, or is the distributor, you're distributing it. Okay, so negative 5x plus a negative 2. Right? And so then we want to line up our variables. So 2x plus 3y plus a negative 4. Or we want to line up our like terms. And then we have negative 5x's plus, we have 0y's, so I'm going to put 0y just to be a placeholder, and then plus a negative 2. Okay, so combine our like terms. We have these with no variable, we call our constant, so it's negative 6 plus 3y, so there weren't any other y's in the other one, plus 5 and 2, but it's a negative, so we're subtracting. Keep the sign of the greater absolute value. Negative 3x plus 3y plus a negative 6. Shouldn't have two signs. So negative 3x plus 3y minus 6. Okay, in example 5, we are looking at it in division. So in the opening exercise, we looked at the proof of the opposites dealing with subtraction and changing it to addition. So here we're looking at it with division because we need to be able to change division to multiplication. Okay, so if we look at that very first row, we see what was given was 3, the multiplicative inverse of 3. So we call it our reciprocal. But it means the same thing. Show that their product is 1. So 3 times 1/3 is 3 over 1 times 1 over 3. 3 times 1 is 3. 1 times 3 is 3. So therefore, our answer is 1. It's 3 over 3 equals 1. So then use each inverse to write its corresponding expression below in the standard form. So we have 12 divided by 3. We know 12 divided by 3 is 4. Okay, but we're showing that we can do the multiplicative inverse. So we're showing that it works here too. So 12 times 1/3. So just so you can see it, that would be 12 over 1 times 1 over 3, which is 12 over 3, which is 12 divided by 3. Okay, so the reciprocal or the multiplicative inverse of 5 is 1/5. So 5 times 1/5 is 5 over 5, which is equal to 1. So 65 divided by 5 is the same thing as 65 times 1 over 5, which would be 65 over 5, which is equal to 13. Okay, so the opposite of negative 2, or the reciprocal of negative 2, is negative 1/2. So negative 2 times a negative 1/2 is, put it over 1, so negative 2 is a negative times a negative is a positive. So then 2 over 2 equals 2, 1. So negative 18, not a negative 18, sorry, positive 18. 18 times negative half is equal to, so basically negative, because a negative times a positive is a negative, and then 18 divided by 2, which is 9. Okay. So those three are ones that you would already you know how to do that division. It would be things that you already know. When it starts becoming a little more important and useful to you is when you're dealing with like a fraction like this one. So the reciprocal would be negative 5/3. Okay, so negative 3/5 times a negative 5/3 is negative times a negative is a positive, so just 15/15. So here, multiplying by the reciprocal is the term that you learned of keep, change, flip. You're multiplying, changing that division to a multiplication sign, and doing the reciprocal of it. So 6 times 5 is 30, and it's a negative. Positive times a negative is a negative. Negative 30, and then 1 times 3 is 3. So negative 30 divided by 3 is a negative 10. And then what we're going into more using is the variables. So the reciprocal of x is 1/x. Just like when we had it was 3, we just put a 1 over it. Okay. So then x times 1x equals x over x. And anything over itself, doesn't matter what that number is always going to be 1. Okay, so then we have 5x times 1x equals, well, we got 5x times 1 is 5x, and then over x, which is equal to 5 times x over x if we just separated that out. So anything divided by itself again is 1, so the answer here would be 5. And lastly we have 2x, and so that would give us 1 over 2x. When we multiply 2x times 1 over 2x, we get 1. So then 12 times the reciprocal, equals 12 over 2x. And so then we can, who's next? Oh, this was 12x, sorry. Okay, so this is 12 over 2 times x over x. You are multiplying 12 times x and 2 times x. Okay, so this is equal to 1, and 12 divided by 2 is equal to 6. Okay, so you're given some of those vocabs that we went over in lesson 1 again to sum up this lesson. Why can't we use any order grouping directly with subtraction and division? They're not commutative. They don't have the commutative and associative properties, so we have to change them to addition and multiplication. And so how can we use it? Well, we have to change it. We have to do the additive inverse and the multiplicative inverse. So our lesson summary tells us all of these things. It has it written for us. So we rewrite subtraction as adding the opposite before we do any order or any grouping. So before we do those properties. Anytime we have division, we rewrite division as multiplying by the reciprocal before we regroup. The opposite of a sum is the sum of its opposites, so that was what we started our lesson with today, and the division is equivalent to multiplying by the reciprocal. Okay, so we're talking about our opposites there. And that is all.